Hello everyone, welcome back to Geometry for Lesson 1-2, Measuring Segments. Now, a lot of the stuff in this lesson is going to seem like common sense, but again, we're only on the second lesson of geometry, so that's okay. And if you find any of this difficult, that's also okay. This is a video, feel free to pause, rewind, do whatever you got to do. So, this lesson, Measuring Segments, is really just about figuring out the distance of segments. We're not yet on a two-dimensional scale. We'll get to that a little later in this unit, but we're talking more just, one-dimensional, figuring out the distance between 2 points. And there's this fancy definition of distance up here that says between any 2 points is the absolute value of the difference of the coordinates, which is basically just a way of saying, figure out how far away A and B are. And you can do that by really going either way, subtracting B from A or A from B, and figuring out the absolute value of that, because distance is never going to be negative. So if you subtract B from A, and B is a larger number than A, it's going to give you a negative number, but distance is not negative. So you would want to take the absolute value of whatever you get. And the distance between A and B is also called the length of AB, or just in general, AB. And that's actually pretty important. Remember in the last lesson we were talking about how you have to have symbols above your name to say if it's a line segment or a line. Well, in the case where there's no symbol above the name of the segment they're giving you, that's when basically it means find the measurement of AB. If they wanted to just talk about segment AB, they would write AB with the little segment symbol. But when there's an AB without the segment signal, that's the same thing as basically saying what is the measure of AB. So let's take a look at these example problems, and you're going to see this is really, really simple. So the first question, we're looking at this first number line, and it says find each length. So the first length they tell us to find is BC. Now, really, all you have to do here is figure out how far away is C from B. And you might think this is really simple. Well, B is at 1 and C is at 3, so they are 2 away from each other. So the distance here is going to be 2. Now, the times when people run into issues is when they're dealing with a negative. So this question says BC again, so I'm gonna change that because that doesn't make any sense. Let's find AC. Now the problem is people run into issues when they're thinking about negatives. So this is the case where if I'm going from A to C and I know A is -2 and C is 3, if I can't really just think of how far away those are from each other, this is a situation where I'm going to subtract the two numbers from each other and find the absolute value. So one of them is -2, one of them is 3. As long as I use the absolute value, it doesn't matter which one I subtract from the other. So I'm going to start at 3, and I'm going to subtract -2, and I want the absolute value of this. So 3 minus -2, well, we have a little trick, right? If we're subtracting a negative, that's the same thing as adding. It's positive, so 3 plus 2 is 5. The absolute value of 5 is 5. And again, you might have just been able to look at that and say, all right, well, -2 to 3, I'm going 5 spaces. That's totally fine. You're allowed to do that. You don't have to, plug into an equation if you understand what's going on. Now, the next one, we're looking at our next number line, which is right here. And the first question says, what's the distance from X to Y? Well, X is 1.5. Y is 5. So again, you can just think like how far away is 5 from 1.5. But let's just do an equation for argument's sake. We're doing 5 minus 1.5. And I want the absolute value of that. So 5 minus 1.5, well, 5 minus 1 would be 4. So if now 1 is 1.5, I'm not going all the way to 4. I'm actually just going 3.5, right? So I have the absolute value of 3.5. Which is just 3.5. So that would be the answer there. Now the next one is X to Z, so I don't really care about this Y anymore. Now I'm looking from X to Z, which is -3. Now I think in this situation, it's a lot easier to actually think, well, -3 is 3 away from 0, and then I'm going another 1.5, so 3 plus 1.5 is 4.5, and then there would be my answer without having to plug into a formula. But just for argument's sake, let's look at what we would do with the formula. So I'm going from -3 to 1.5, so I would say, all right, well, -3 minus 1.5, and I want the absolute value of that. Now, I'm taking a negative number and I'm subtracting. So if I'm taking a negative number and I'm getting more negative, I'm just going to add those two numbers. 3 plus 1.5, I'd get -4.5. But remember, distance can't be negative, so I take the absolute value, and I get that same answer that I got before just from kind of thinking about it, 4.5. All right, so now we're getting to a big concept in geometry, the concept of congruency. And you're going to see throughout geometry, we're going to talk about congruency a lot. Now, one of the easiest things to talk about with congruency is congruent segments, which are segments that have the exact same length. Now, when we talk about the word congruent, congruent means that something, some shape, has the exact same measurements of another shape. A lot of people tend to switch around the words congruent and equal, which is understandable, but they're not the same thing. When you talk about something being equal, you actually are talking about numbers. If you have exact numbers, you can say, all right, they're equal. But if you're using the word congruent, it means that you know that the measures are the same, but you don't actually have specific numbers that you can set equal. All right, so in this diagram right here, they're saying PQ and RS are congruent. Now in geometry, we like to show that segments are congruent using these little things called tick marks, which is really just like a little line going through the line. The symbol that we use for congruency is this little equal sign with a squiggly above it. And again, that symbol says is congruent to. So when I say PQ with a line above it is congruent to RS with a line above it, I'm just saying PQ is congruent to RS. And again, it is important with right here, this is actually wrong. It is important to have these little segment symbols over our names, because if we don't have that, then we're saying the measure of PQ. We're not saying PQ, we're saying the measure of PQ. And if we're talking about the measure of PQ, the measure of PQ is a number, so we wouldn't use congruency. We would use an equal sign. So if we're talking about measures, so if we don't have a symbol, we're not going to use the congruency sign. We would use the equal sign. And then that last sentence, I already went over that. These tick marks tell us that things are equal. Now, if we had multiple lines around here, so let's say I have PQ, I have RS, but now I also have AB and CD, and let's say AB and CD were congruent, but they're not congruent to PQ or RS, I would actually use a little double tick mark to show that if both of these have double tick marks, then AB would be congruent to CD, but they're not congruent to PQ or RS because they have a different type of tick mark. Okay, here we have another postulate. Remember from the last lesson, a postulate is something that people just believe to be true without any sort of proof, and you're going to see this postulate really does fall into the realm of postulates. It's a very obvious thing. So this is called the segment addition postulate. And basically all it says is that if I have a point between two other points, in this case it's B, is between A and C, what this postulate says is that if I know the measure of AB and I know the measure of BC, then I can add those measures up to figure out the total measure of AC. That makes sense, right? Like if I have two pieces that come together, I can figure out the total measure of the entire segment. So, as an example, just to show you an example of how easy this is, G is between F and H. So, the first thing I want to do, before I even read further, is draw a picture. In geometry, whenever you're dealing with any sort of problem that includes numbers, you want to have a picture. It makes your life a lot easier. So, I have F, I have H, I have a line that connects them, And they're saying G is somewhere between them. So I'm just going to put a G right here. And then it says FG is 6. So I know this measure is 6. And then they actually tell me the entire measure. The entire measure from F to H is 11. The question says find GH. Well, this is actually an example of how we can use segment addition postulate kind of backwards. So in this case, I know this measure from F to G plus the measure from G to H has to equal the entire measure from F to H. They told me F to H is 11, so I know 6, which is FG, plus whatever FH is, has to equal 11. So how do I solve for FH? I just subtract 6, and I find out that FH equals 5. So here's some examples that use a little more algebra, which is good because you guys just took algebra last year, so you should be refining your algebra skills. You're taking algebra 2 next year. So again, you don't want to lose those skills that you gained in algebra 1. So in this case, M is between N and O. So I know, again, based on this diagram right here, NM, from the distance from N to M, plus the distance from M to O, has to equal the total distance from N to O, right? Now that I made that equation, I can now substitute in all those measures. So I know NM is equal to 17, plus MO is represented by the expression 3x minus 5. And that's going to equal NO, which is represented by the expression 5x plus 2. So again, now we're practicing those algebra skills. On the left side of the equation, I can combine 17 and negative 5. 17 minus 5 is 12. 12 plus 3x is equal to 5x plus 2. When I'm solving an algebra, I want to get all of my x's on one side, all of my constants on another side. So I am going to subtract 3x to the right side of my equation. And while I'm doing that, to cancel out the x, I'm also going to say, all right, well, if I'm moving the x's to the right, I'm going to move all my other numbers to the left. So I'm going to subtract this 2 to get rid of that. And what I wind up with is 12 minus 2 is 10. And that's going to be equal to 5x minus 3x is 2x. So if 2x equals 10, divide by 2, x equals 5. And that's the answer to number 6. I know I just kind of went into the space of number 7. That's okay. So my answer is x equals 5 in this case. And if you remember anything from algebra, it is common practice to check if we're correct. So we might want to go ahead and plug this 5 in to all of our x's and see if we're right. So NM is 17. There's no x's there. MO is 3x minus 5. So 3 times 5 is 15. Minus 5 is 10. So I'm just going to put a little 10 there. Now, NO is represented by 5x plus 2. X is 5, so 5 times 5 is 25. 25 plus 2 is 27. And in this scenario, is 17, right there, plus 10 equal to 27? Yeah, so we got it right. We got our x correct. Now let's take a look at number 7. You might want to pause the video and try this one on your own just to get a little practice. So hopefully you just paused it to get a little practice. Let's go over it. So E is between D and F. So that tells me my equation is going to be DE plus EF equals DF. Now that we have our equation written out, we can substitute in all of our formulas, all of our expressions. So DE is represented by the expression 3x minus 1 plus EF, which is just 13, equals DF, which is 6x. Now again, we're going to use some algebra. I am going to combine like terms on the left side. So negative 1 plus 13 is 12. So 3x plus 12 equals 6x. Then I want to get all my x's on one side. Well, I could subtract over the 6x, but that would be weird, right? Because we would just be equal to 0 at that point. And I would wind up having a negative x, so I'm going to subtract the 3x actually to the right side of the formula. That cancels that x out. 6x minus 3x is 3x, so I get 12 equals 3x. Divide by 3, I get x equals 4. And again, we should check this. So let's plug these all in. So DE is represented by 3x minus 1. If x is 4, 3 times 4 is 12. 12 minus 1 is 11. I already know EF is 13. That's fine. Then DF is represented by 6x. 6 times 4 is 24. Does 11 plus 13 equal 24? Yeah, it does, so we're correct. All right, so then the last idea of this lesson is the midpoint. Basically, a midpoint of a segment is going to bisect, which is a word that we're going to see a lot in geometry. Bisect really means just to divide in half. So it's going to bisect the line segment, meaning that if I have, in this case, if M is the midpoint of AB, so if I have a drawing here where I have A and B, and I have this point M somewhere between A and B, but they're telling me M is the midpoint, it's going to create two exact congruent segments. So in this scenario, let's say if AB was, like 34, and M was the midpoint, that would mean AM would be 17, and MB would be 17, because it would split it directly in half. Now, this application problem is actually pretty difficult, so we're going to jump ahead to the next problem, and then I'm going to come back to this application problem. All right, so here's an example problem that's a little easier than that application, so let's try this first. So this question says, D is the midpoint of EF. So again, before I even look at the rest of the question, I should draw this picture. So I have some line EF, and they're telling me D is the midpoint, which tells me D bisects EF, which means it cuts it directly in half. Then they tell me ED is 4x plus 6, 4x plus 6, and DF is 7x minus 9. Then it says find ED, DF, and EF. Now, this might seem like a difficult problem because they're not giving you any actual numbers. They only give you expressions. However, since we know D is the midpoint, like these tick marks are now showing us, we know that ED and DF should be the same measurement, meaning those expressions should be equal. So 4x plus 6 should be equal to 7x minus 9. And now we just use a little algebra to solve. So again, we're going to get x's to one side, our other numbers to the opposite side. So if I'm deciding to subtract 4x to the right, to get rid of that 4x, that means I should be moving the numbers to the left. So I'm going to add 9 to the left. 6 plus 9 is 15, equals 7x minus 4x is 3x. So divide by 3, I get x equals 5. Which is great, but if I stop here, I didn't get the question correct. The question did not say solve for x. The question said find ED, DF, and EF. So I have to do that. So what I need to do is I now need to take this x and plug it in to 4x plus 6 and 7x minus 9 to find ED and DF. Well, actually, I really only need to plug it into one of them because I know they are equal, right? That was the whole reason I was able to set up the equation to begin with. So if I'm going to try to find ED is 4x plus 6. So I take my x, which is 5, plug it in for x. 4 times 5 is 20. 20 plus 6 is 26. And if I know ED is 26, then DF also has to be 26. And if I know those are both 26, EF is the entire segment. So due to segment addition postulate, EF has to equal ED plus DF. So I add those together, I get 52. Okay, now let's take a look back at this application problem. The application problem says the map shows the route for a race. So I guess in this race we're going from X to Y, considering it says we're starting at X. It also says X is 600 feet from the first checkpoint C. So we know that the distance from point X to point C is going to be 6,000 feet, right? Then it says the second checkpoint, D, is located at the midpoint between C and the end of the race, Y. So we know D is the midpoint, so we can throw these tick marks in, showing that D bisects CY, and that CD and DY need to be the exact same measure. Now, the hard part of this is that the question now kind of shifts and says the total race is 3 miles. Well, that's kind of weird because when they gave us our first distance, they gave it to us in feet. So I'm going to need to convert some way from feet to miles. Luckily, if you don't already know this measure, which I'm assuming most of you guys might not, is we have Google, right? So we can look up that 1 mile is equal to 5,280 feet. But we're not going 1 mile, we're going 3 miles. So we're going to have to say, all right, well, we're going to multiply the amount of feet and miles by 3, and I get 15,840 feet, which is nice. Now I have everything in feet, so I can actually figure this problem out. So I know the total race is 15,840 feet. I've already gone 6,000 feet, so now I need to subtract 6,000 from 15,840. That's going to give me 9,840. So that's how much of the race is left. And I know if this whole thing is 9,840 feet, I know D is the midpoint. So that means from C to D and D to Y is going to be exactly half of 9,840, which is 4,920 feet. So that's the answer to my question. The two checkpoints, C and D, are going to be 4,920 feet apart from each other. Okay, so that's the end of lesson 1-2. I know this question that we just did was a little difficult, but hopefully you understood the basics that we went over, how to measure a segment, segment addition postulate, congruent segments, and midpoint. If you are still having trouble with any of those concepts, again, this is a video, so you can just rewind and listen to those parts over again until you get it. Or, feel free to use Google. Google's our friends to look anything up if you are really confused about it. And obviously, if none of that works, jot down a note that you are confused about something so that when we meet face to face, you can ask me any questions that you have. All right, have a great rest of your day.